So good morning, boys and girls. Happy Thursday. Today we're going to be working on Module 15, Lesson 3, Compare Fractions with the Same Numerator. And if you turn to page 409 in your books, you can follow along. Let's start off with the I can objective. It reads, I can compare fractions that count the same number of equal parts when the whole is divided into a different number of equal parts. So let's break down this objective and see where we can build from things that we've already learned and see what we're going to learn new today. Okay, so we've already identified numerators and denominators and what those mean. So in my I can objective, I see that we're comparing fractions that count the same number of equal parts when the whole is divided into a different number of equal parts. So that's telling me that today we're going to compare fractions where the parts we're counting or the numerator is going to be the same, but the whole is divided into different number of equal parts. So my denominator this time will be different. We already know that wholes in models must be the same size. Whether we're creating a bar model, whether we're creating circles and shapes or cookies, or even number lines, we have to make sure that our models are the same size in order to accurately compare the fractions. And we know that when we're using fractions and we're breaking them into parts, those parts must be equal. So can you think of two fractions that have the same numerator but different denominators? I'm sure you can come up with a lot of them. So 2/3 and 2/4, they both have a numerator of 2, but their denominators are different. That's just two fractions with the same numerator and different denominator. So let's go ahead and dive into our lesson. Okay, so let's start with the build understanding. And remember, when I read the problem, boys and girls, you're making a picture in your head so that you know what the situation is about. Number 1, Alon and Tanya both plan to film 1-minute videos. So far, Alon has filmed 2/6 of his video. Tanya has filmed 2/3 of her video. Who has filmed less so far? Well, what is this problem talking about? I know that there's two people and they're each filming videos. I know that each of their videos are the same size because they're both going to be 1 minute each. I also see two quantities in my problem. The first quantity that I see is 2/6, and that represents how much video Alon has already filmed. And the second quantity that I see is 2/3, and that represents how much video Tanya has filmed. And the problem is asking us to find the person who has filmed less so far. So let's take a look at A, show one way to solve the problem. Well, in my rectangle, I see two bars and they're already labeled. What do you notice about those bars? Well, they're the same size. So remember how important it is to make models that are the same size, wholes that are the same size when we're comparing fractions. And my bars are already labeled with Alon's name and Tanya's name. So I'm going to go ahead and I'm going to write the fraction that belongs to each of the people right next to their name. How do these fractions help me to understand how to break up my whole? Well, by looking at the denominator, I know that Alon is going to break up his bar into 6 equal parts, or sixths. And Tanya is going to break hers up into thirds, or 3 equal parts. And I use the top bar as a guide to see how I could break it up into thirds. And now let's fill in, or let's shade how much of the video they've already filmed so far. I noticed that my numerator for each person is a 2. So they've filmed 2 parts each. So 2 parts out of 6 and 2 parts out of 3. Do you notice anything? Well, I notice that Tanya's 2 parts are a lot bigger than Alon's 2 parts. So it says B, write less than, greater than, or equal to compare the fractions. 2/6 and 2/3. Well, 2/6 was smaller than 2/3, so the symbol would be for less than. And the symbol for less than looks like this. The opening is pointing towards the right. C, who films less of the video? How do you know? Well, Alon films less. And we know because we compared our models and we see that 2 parts out of 6 is less than 2 parts out of 3. Let's take a look at number 2. Rocky hikes 5/6 of the Pinot Trail. Rini hikes 5/8 of the trail. Who hikes a greater distance on the trail? Well, I see that I have 2 number lines this time instead of my bar models. And I don't have them labeled. What can I do to know which number line belongs to which person? That's right. If I look at the person and the fraction that they have, it gives me a denominator. So I know that Rocky is hiking has hiked 5/6 of the trail. So I'm going to look for the number line that is counting by sixths, and that would be the first one. So I'm going to go ahead and put his name right here. And I'm going to put a 5/6 right on the side so that I organize my work and I remember how much he's hiked already. And then Rini hikes 5/8, and the other number line is broken up into eighths. Okay. And now all that's left for us to do, boys and girls, is to go ahead and find out where 5/6 is on the number line and 5/8 is on the number line. So let's go ahead and label it. Well, for Rocky, we're starting at 0/6. Okay. How many jumps do we have to make on our number line if we're counting by 1/6 each time? 5. So let's go ahead and make our 5 jumps. 1/6, 2/6, 3/6, 4/6, 5/6. Look at that. Rocky has hiked all that way. He's really close to the end of the trail, to the whole thing. And now let's take a look at Rini. I notice that my numerator is the same, so I'm going to also make 5 jumps. But as I make these 5 jumps, boys and girls, I want you to take a look at the size of each of the jumps that I'm making. So we start at 0/8. 1 jump is 1/8. 2 jumps is 2/8. 3 jumps is 3/8. 4/8. And the last jump, 5/8. So Rini is that far into the trail. So A, how can you show the distances on the number lines? Well, we can show it by counting by the unit fraction until we get to the fraction of the trail that they've hiked. And which fraction is closer to 1? Well, Rocky's here, and Rini's here, and you see where the 1 is, so who's closer? Rocky. And B, write less than, greater than, or equal to compare the fractions, 5/6 and 5/8. Well, 5/6 is greater than 5/8. It's closer to 1. So we would write our greater than symbol. Now remember, boys and girls, the greater than symbol, the opening points to the left. So who hiked farther? Rocky did. Okay, now let's take a look over at the other side of the screen on the right. And I want you to picture your favorite pizza. Okay, look at those parts. How many equal parts is that pizza cut into? Yeah, it's cut into 4 equal parts. So my denominator is a 4. Now imagine the same size pizza, but cut into eighths. What do you notice about the parts in each one? And now imagine you really have to share it with a lot of people. And it's your same size pizza, but now it's cut into 16 equal parts. So your denominator would be 16. You see 3 same size pizzas, and they're each cut into equal parts, but they have a different amount of equal parts for each one. So their denominators are different. And now I'm going to give you the same numerator on each one. I want to count just one of those parts. So I'm going to go ahead and shade one part out of the 4. I'm going to shade one part out of the 8. And I'm going to shade one part out of the 16. If you were really hungry and I said to you, you can have one part out of any of these pizzas, which one would you choose? Well, I would choose the first one part out of the 4, because the piece is bigger. So boys and girls, when your numerators are the same, we take a look at the denominators to help us decide which fractions are bigger and which fractions are smaller. Remember, the greater your denominator gets, the smaller those pieces are going to be. So even though you're counting the same amount of parts in your numerator, the size of the parts are going to change. So if you want a bigger fraction, then you want your denominator to be smaller. And if you want a smaller fraction, you want your denominator to be greater, because that means that you're dividing the whole into more and more equal pieces. Now let's try to step it out. Aiden climbs 2/9 of the way up the rope ladder. Reed climbs 2/5 of the way up the same rope ladder. Who climbs higher? How do the numerators compare? Well, let's see. We know that Aiden climbs 2/9, and we know that Reed climbs 2/5. What do we notice about our numerators? Our numerators are counting the same amount of parts. Okay, so let's look at B. How do the denominators compare? Aiden, the whole is divided into how many parts? That's right, 9. For Reed, the whole is divided into 5 parts. So think about a whole and think about dividing it into 9 parts. And now think about a whole the same size and you're dividing it into 5 parts. Which one is going to have parts that are larger? That's right. Reed's parts are going to be larger because she's dividing it into less amount of parts. Okay, and now finally look at C. Are 2 of the equal parts in Reed's climb smaller than or larger than 2 of the equal parts in Aiden's climb? Well, Reed's 2 parts are larger than Aiden's 2 parts. So they're larger. And then compare the fractions. 2/9 and 2/5. Well, 2/5 is larger, so 2/9 is less than 2/5. Who climbs higher? Reed does. Okay. And if you'd like to see a bar model for that, I'll go ahead and do that. Now, you'll notice that as I make my models, boys and girls, I'm making them the same size. One is going to be for Aiden, and the other one's going to be for Reed. So, for Aiden, I'm going to break it up into how many equal parts? That's right, 9. My denominator is 9, so I'm going to break it up into 9 equal parts. Okay, and for Reed, I'm breaking it up into 5 equal parts. Okay, and if I go ahead and I shade in 2/9, those parts are smaller. And now I'm going to shade in 2/5. Those parts are a lot larger. So I know that Reed climbs higher. All right, boys and girls, it's your turn. You're going to pause the video here, and I want you to complete the check understanding and the on your own. Once you're done, come back and we'll review it together. Hi, boys and girls, welcome back. Let's see how you did. Let's start with the check understanding. Roxanne paints 4/6 of a poster red. Max paints 4/8 of the same size poster red. Who paints more of their poster red? How do you know? So Roxanne paints 4/6 and Max paints 4/8. I do notice that my numerators are the same, so I'm counting the same amount of parts. And since I want to know who painted more, I want to know which one is counting parts that are larger. So I have a 6 in the denominator and I have an 8 in the denominator. So the 4/6 is going to have larger parts because I'm breaking my whole into less parts. So 4/6 is greater, which means that Roxanne painted more. And I can make a quick model for you down here. Remember, when you're making your model, they have to be the same size. So for Roxanne, I'm going to separate it, divide it into 6 equal parts. And for Max, I'm dividing it into 8 equal parts. Okay, and I know that they each painted 4 of those parts. 1, 2, 3, 4 parts out of 6, and 1, 2, 3, 4 parts out of 8. So my answer is correct. Roxanne did paint more. Compare. Write less than, greater than, or equal to 3/4 and 3/8. Since my numerator is the same, I take a look at my denominator. Okay? The more parts I break it up into, the smaller those parts are. So 3/4 is greater than 3/8. 2/5 and 2/3. My denominator is the same, so I'm looking at my numerator is the same, so I'm looking at my denominator. I want to count 2 parts in my numerator, and in one fraction, my denominator is broken up into 5 equal parts, and in the other one, 3 equal parts. Well, if I break it up into 3 equal parts, those parts are bigger, so 2/5 is less than 2/3. And then we're comparing 4/6 and 4/4. My numerator is the same, So now I compare my denominators. I have 6 equal parts or 4 equal parts. Well, 4 equal parts would give me bigger parts. So 4/6 is less than 4/4. What do you also notice about the fraction 4/4? It equals 1 whole. And I know that 4/6 is less than 1 whole, so 4/6 is going to be less than 4/4. Let's finish up the on your own. On a hike, Lily eats 2/3 of her granola bar. Pat eats 2/4 of his granola bar. Both bars are the same size. Who eats less? Explain your answer. Well, let's go ahead, and this one will be Lily's, and this one will be Pat's. Lily's, I want to break it up into 3 equal parts. And Pat's, I want to break up into 4 equal parts. And they each eat 2 of their parts. Okay, so who eats less? Well, Pat eats less because his parts are smaller. Compare the fractions, write less than, greater than, or equal to. 3/4 and 3/6. Well, let's think about it. Our numerators are the same, so now we look at our denominators. We have 4 equal parts or 6 equal parts. 4 equal parts would be bigger parts because they're broken up less amount of times. So 3/4 is greater than 3/6. Let's look at number 7. Our numerators are the same. We're counting 4 parts in each. And our denominators are the same. What symbol would we show when 2 fractions are the same? Right, the equal sign. So 4/8 is equal to 4/8. And number 8, 5/3 and 5/8. Our numerators are the same and our denominators are different. So 3 parts would be greater than 8 parts. So 5/3 is greater than 5/8. I also notice that this fraction is a fraction greater than 1, and 5/8 is less than 1. Igneous rocks, such as feldspar, form when different types of melted rock deep inside the earth cool and harden. Igneous rock sample A is 3/8 feldspar. Igneous rock B is 3/5 feldspar. Both rocks weigh the same. Which rock has a greater amount of feldspar? Explain. So boys and girls, again, the numerators are the same. So I know that I'm counting the same amount of parts, 3 parts. And then what's left to look at is our denominator. Okay? Sample A is broken up into 8 equal parts. Sample B is broken up into 5 equal parts. We're looking for the greater amount. So we're looking for the smaller denominator. So 3/5 would have the greatest amount of feldspar. Okay, so let's wrap this lesson up and let's build on things that we already know and that we learned in today's lesson. Okay, when we're using models to compare fractions, we have to make sure that each whole is the same size. Whether you're using number lines or bars or shapes, you need to make sure that your models are the same size to accurately compare the fractions. And if the numerators are the same, look at the denominators. The larger the denominator, the smaller each part you're counting will be. Okay, so boys and girls, let's take a look at their Nearpod codes. Okay, for English, your code is PBNYQ. Meninos e meninas, o vosso código para o Nearpod é LTEPC. Y niños, para el código en español para Nearpod es WIFI. I, F, A, J. Please be sure to take your time answering these questions. Have your notebook out, draw models if you need to help you to visualize each of the fractions. And don't forget to like and subscribe. If Tyler were here, he would tell you himself. I will see you tomorrow. Call me, email me, text me with any questions, boys and girls.